Hello guys, how are you all? I hope everyone is doing great. Welcome to Mechanical Training World. If you are new to my channel, please subscribe my channel and click on the bell icon so you will receive further videos as a notification. If you like my content, share to your friends also so they will also get benefited. So let's get into the topic guys. This is the 8th lecture of ASME BPVC Section 8 Division 1 training, that is UG-16 General Design Requirements. This UG-16B says that the minimum thickness required for pressure retaining components after forming must be 1.5 mm thickness, excluding corrosion allowances. So, what are the pressure vessels you are designing that must be 1.5 mm or above thickness? So, then only your design is considered as per ASME Section 8 Division 1. Otherwise, this code is not applicable for that components. So, this code given some exceptions for some of the parts about minimum thickness. Let's see. The first condition is the minimum thickness requirement does not apply to plate type heat exchangers and double pipe type heat exchangers and air cooler type heat exchangers. Why code given like this? Why given code exception for this heat exchangers means because in heat exchangers we use plates for heat transferring. So for heat transferring, the plate thickness must be less than as much as the minimum. So that's why the code given exception for this heat exchangers. I hope you understand the first point. And next one is it does not apply to unfired steam boilers. Why? Because the minimum thickness required for head and shell for unfired steam boilers is 6 mm. It must be 6 mm. Okay, 6 mm and above. Then only the code accept this one. So next one is it does not apply to compressed air, steam services, and water services because for these services, the plate thickness must be above 2.5 mm. Okay, I hope you understand. And we go to next point. And UG-16C, that is plate under tolerance. We know under tolerance means negative tolerance. So, for example, the plate thickness as per code is 11.85 mm. For example, what you have calculated the design thickness is so 11.85 mm. So, but in the market, 11.85 mm thickness plates are not available. So you ordered 12 mm thick plates. So after receiving the plate, if you measure the thickness, if you measure the thickness, there is a some deviation in the plate. So if you measure the thickness of the plate throughout the length, you will definitely observe some deviations because it is not possible to manufacture a plate with exact 12 mm thickness for any manufacturers. So, okay, so that's why you will observe some deviations in the plate. So if the deviation is positive side, that is 12.12 like that, that is positive side, we have no problem because code says that our design thickness must be less than order thickness. Then only code satisfies. Otherwise, code does not satisfy. In here, 11.85 is our design thickness, so positive tolerance is acceptable. We have no problem as per code. If it is negative, like 11.75, so this is less than our design thickness. So code does not accept this one. So that's why code given the one condition. The difference between the actual thickness of the plate ordered, that is 12 mm, the design thickness as per code, that is 11.85 mm, shall be less than 0.3 mm. So the difference must be 0.3 mm or less. Then only code will accept. For example, 11.85 mm is our design thickness and our negative tolerance is 11.75 mm. So the difference between two values less than 0.3 mm, then only your received plate is okay for your design. Otherwise, it is not okay. So that is the intention of this point. I hope you understand this point. So next one is UG-16D, pipe under tolerance. So the pipe under tolerance for pipes, the under tolerance requirement is based on the piping specification. It does not depend on the ordered thickness. Okay, the pipe specification it depends on the pipe specification. For different material pipes, there is a different deviation is there. For example, if you take for carbon steel pipes as per SA 106, the thickness deviation is not more than 12.5. percentage of wall thickness. So for example, your design thickness is 9.2 mm. You ordered thickness is for example 12 mm only. So you ordered one pipe, right? This is your pipe. This is your pipe. Okay. This pipe thickness, whatever you received, it shall not be less than. I will calculate here. You ordered this 12 into, you need to consider this 12.5 percentage. So 100 minus 12.5, that is 0.875. So you need to divide by 100, right? So that's why 0.875. So you will get around 10.33, like 33, 33 mm. So it is greater than our design thickness. So as per code, there is no problem. If this value is less than our design thickness, then we have a problem with that ordered component. So I hope now you understand this point. Okay. Next one, that is UG-16E corrosion allowances. It states that all the design formulas given in this code was in corroded condition only. So what are the formulas you are saying in this code that are in corroded condition only? For example, here it is there, right? So if you, this is 150 mm, 150, okay, and you calculated that thickness is 10 mm, okay, and this is corroded condition. So after 12 years, this corrosion will be gone, right? Then what is your ID? ID of your pipe. Then what is your ID of the pipe? So if you know the answer, please comment in our comment box. So I will tell you. For example, after 12 years, uh, your corrosion will be gone. So uh, for example only. So at that time also, your ID is 150 only. Why? Because the code says that all the dimensions what you are seeing in this code that are must be in the corroded conditions only. See all these formulas what you are seeing in this code that are in corroded condition. Okay. So in any industry we design a pressure vessel for at lifetime. That is at last day of that at last working day of the pressure vessel. So we need to consider that day. Need not to design at first day condition. Okay, we need to design for most severe condition, so that is without corroded condition. So I hope you understand this session. If you like my video, please share to your friends. Thank you guys.